Question 42. 4 students were asked to create a graph representing a typical predator-prey relationship. So, they're graphing predator-prey relationship. Alright. So we've kind of talked about this a lot. If the number, remember the predator is a hunter, and the prey is the hunted. Let's make it some example. Let's say this is a wolf, and this is the deer. If the number of deers go up, then the number of wolves will go up. Because the more deer there are in an area, the more wolves it can support because they have something to eat, right? But, in contrast, if the number of deer should decrease, then what's going to happen to the number of wolves? Well, if there's not that many deer, some of these wolves are going to go hungry, so either they're going to leave the area or die because they don't have food. So they'll probably find a new habitat, leave, and go somewhere else. But as the number of deer decline, then so would the number of wolves in a population. So it says, which graph shows a situation in which the number of predators in a population depends on the number of prey? So let's see. Alright. Looking at the graphs, graph number A shows there is maybe 10, let's say that's 10, I'm just making this up, 10 prey, and there's a whole bunch of the number of predators are increasing. Well, they can't go up because there's not enough prey. So this realistically would be if there's 10 of these, there's probably only so many of these that would go with it, probably less than 10. Probably here would be the line. That would be more realistic for the predator. So this graph is nonsense. Graph B. I don't know what happened here because there's 0, because this is a 0 line right here. So there's 0 and the increase in predators, that's just totally craziness. Alright, here we're looking at the number of prey gradually increasing in number because that's the population here, that's the number, and over time, so they're gradually increasing, and then the number kind of levels out as to how many prey there are. But if we're looking at the predators just kind of stays on one stagnant line. They don't increase with the number of prey, so that doesn't make any sense because they both are going to be correlated. Okay, here if we look at this one, and this is a population, these are the numbers of organisms over time. So we can see that the prey, there's a lot of prey, and they're increasing and then they kind of decrease somewhat. Okay, and we look at the predators. Predators have a similar line. They're starting here, they're low, they gradually increase with the number of food available, and as the food becomes less available, so do the number of predators. So this is the only graph that realistically shows a predator-prey relationship.